Hey guys, welcome to our new lesson. We are starting chapter 11, which will be the last chapter for this school year. Okay guys, so exciting stuff. We have made it here to the end. So let's get started with 11.1, which focuses on inverse variation. And the first thing we are going to do is actually review direct variation. So we did direct variation all the way back in chapter 5. And so this is just going to be a quick little refresher. The direct variation equation is right here. Y equals k times x. That letter k, very important because that will also show up in inverse variation, which is our focus. And the letter k represents the constant of variation. Okay? So the letter k represents the constant. Remember, a constant in math is just a number. So like the number 4, the number 6, any number. In direct variation, again, which is review, both quantities are going up or both quantities are going down. So for example, the more you work, the more money you make, right? As the amount of hours that you work goes up, the amount of money that you make also goes up. So that would be an example of direct variation. A quick little review because that is not the focus of today's lesson. Inverse variation is what we are going to be looking at today. And that word inverse, especially when we use it mathematically, refers to opposites. Okay, when you see the word inverse, we're talking about opposites. So in inverse variation, as one quantity goes up, the other quantity goes down. Okay, look at the example that we have right here. The more people help out, the less time it takes to paint the wall. So as the amount of people is going up, right? So here, as the amount of people is going up, the time is going down. Okay, so that's a real life example of inverse variation. The amount of people there is going up, so the amount of time it takes to paint the wall is going down. And now here is the formula that we're going to be using for all of our examples today. This is the only formula that we're going to focus on for today. Y equals k divided by x. So that is our inverse variation formula. You want to make sure you have that memorized. You will need to know that for the quiz. And how you read this is y varies inversely by x. So that's how you read that formula when you see it in a word problem, something like that. And remember this letter k, just like we talked about in direct variation, the letter k here in inverse still represents the constant of variation. So that letter k, regardless of whether it's direct variation, inverse variation, it always represents the constant. Okay? All right, let's do our first example. And you will have several homework questions like this. Okay? Determine whether the equation represents inverse variation. How can we do that? Remember, a lot of the things we do in math are going to be plugging in. So in order to determine whether this equation is inverse variation, I'm going to plug in. Notice I have two variables, b and w, and they have to equal -2. So I'm going to pick two random numbers. So first, why don't I go with -10 over 5? Doesn't that equal -2? Okay, so -10 would be b, 5 would be w. So there's my first example. Let me do a second example. Something over something equals -2. So why don't I do -20 over 10? Again, it has to actually equal -2. Okay? -10 divided by 5 equals -2. And here on the right, -20 divided by 10 equals -2. So here on the right, in this scenario, -20 would equal b, and 10 would equal w. Now let's go ahead and take a look at our variables. B was originally -10. The second b that I chose was -20. So is my value for b going up or down? From -10 to -20, my value for b is going down. Now let's look at my w. My original w here on the left was 5. my new W here on the right was 10. So from 5 to 10, is my value going up or down? It's going up. So notice, one variable went down, the other variable went up. So is that inverse variation? And the answer should be yes. Okay, because inverse variation means that one value goes up as one value goes down. All right, so these will be the very first few homework problems that you have. Just remember, plug in at least 2 sets of numbers, and then compare. Tell me what those numbers are doing. All right, now let's talk about our steps in using inverse variation. And step 1 is always the same no matter what. Notice step 1 is to plug in the given values of x and y to find the constant of variation. So step 1 can kind of be broken down just to these terms. Find k. Okay? The first thing you always want to do when you're working with inverse variation is find k. Find that constant. Then depending on what the directions say, if the directions ask you to write an equation, then we're going to follow the steps here on the left. All you do is plug k into the formula and leave it as is. So you could have a formula y equals 3 over x, something like that. So if that's what the directions tell you to do, if they tell you to write an equation, that's all you do. If the directions tell you to find values, then you have to follow the path here on the right. If they ask you to find new values, you plug k and the given second values. Okay, so here on the left, finding the equation's a little bit less work. If the directions ask you to find values, like here on the right, we are going to have to do a few extra steps. So let's go through the examples here and you can see what that looks like. So here's my first example. Notice up here on the left, I have my direct variation equation. If y varies inversely as x, that should be your hint to use the equation. So if y varies inversely as x, and y equals 5 when x equals 15, find x when y is 16. So do you see how I have 2 sets of numbers? This is my first set of numbers, and then here I have my second set of numbers. Find x when y is 16. That's my second set of numbers. So the first thing I'm going to do is plug in my first set of numbers to find k. So my original equation is y equals k over x. So instead of y, I'm going to put 5. K is what I do not know. And instead of x, I'm going to put 15. Now remember, when we're solving equations, the goal is to get the variable alone. If k is being divided by 15, the opposite is to multiply by 15. So I'm going to multiply both sides by 15, and when I do 15 times 5, I end up with k equals 75. So I have completed step 1, which is to solve for k. Okay, so I've plugged in, I've solved for k. Now let's do my last step, which is to plug in the new numbers. Now that I have used y equals 5 and x equals 15, you can totally ignore them. Okay, guys, you can cross them out. Once you've used the first set of numbers, we're not going to use them again. So now I plug in the new numbers. So for my new numbers, I'll put new here to make it even more obvious. Y equals k over x. My new y is going to be 16 because here in the problem, they tell me y equals 16. Instead of k, I can now put 75 because we just solved that k is 75. X is now going to stay my variable because look up here at the problem in the top right, it says find x. Okay, so that's my new setup right here on the bottom right. 16 equals 75 over x. Now we just solve for x. To get rid of the fraction, always multiply by the denominator. So multiply both sides by x. On the right, they cross out. So I have 16x equals 75. Now to get x alone, I'm going to divide both sides by 16. And so my final answer is x equals 4.69. So this, guys, x equals 4.69, this would be your answer to the question. Okay, so there are several steps along the way, but your final answer, find x when y is 16, you would tell me x equals 4.69. All right, let's look at our second example. If y varies inversely as x, again, when you see that phrase, you should automatically be thinking, here's the equation I'm going to use. So y varies inversely as x, y is 12 when x is 1/2. Find y when x is 38. All right, let's plug in my first set of numbers. So when y equals k over x, my first set of numbers are 12 and 1/2. So I'm going to have, instead of y, 12 equals k over 1/2. To get k alone, I'm going to multiply both sides by 1/2. On the right, they cross out, and my final answer for k is 6. So here's my constant of variation. Now that I've used 12 and 1/2, cross them out. Okay, guys, don't even get thrown off by them. Now let's plug in the second set of numbers. So here's my original equation, and they're telling me to find y. So I'm going to leave y as a variable. For k, I can now plug in 6 because that's what we just discovered k is. And for x, I'm going to put 38 because that comes straight from the directions. So y equals 6 over 38. So I just put that into the calculator. Remember, my fraction bar is the operation division. So my final answer is y equals 0.16. So this would be your answer to the question. Okay, guys, find y when x is 38. Y is y is 0.16. All right, let's look at our word problem. Okay, so here's our word problem. The intensity with which an object is illuminated varies inversely as the square of its distance from the light source. At 1.5 feet from the light bulb, the intensity of the light bulb is 60 units. What is the intensity at 1 foot? Now, we have to break this down to be able to solve this. And how we read our inverse variation is very important. Y varies inversely as x. So that means y comes first, x comes at the end. So if you see the phrase varies inversely, whatever comes in front of that is going to represent y. So in this word problem, the intensity represents y because the intensity varies inversely as the distance. Okay? So the distance is going to represent x, the intensity is y. So now let's look at our examples, at the numbers they give us. At 1.5 feet, so is that distance or intensity? That's distance. So 1.5 feet would be x. So at 1.5 feet, the intensity is 60 units. So this is going to represent y. So basically what they're saying is when x is 1.5, y equals 60. That's the first set of numbers they're giving me. Then the second set of numbers that they're giving me, what is the intensity? So remember, the intensity is represented by y. So find y at 1 foot. So this would be distance. Okay? So what they're saying is that you are given x is 1.5, y is 60. They want you to find y when x equals 1. Okay? So we have to take this word problem and break it down into something we're familiar with. Now that we've done that, we're doing what you guys should be comfortable with. The first step is to plug into the equation to find k. So y equals k over x. Let's plug in my first set of numbers that have been given to me. So for y, I'm going to put 60. K is what I'm looking for. For x, I'm going to put 1.5. To solve, I multiply both sides by 1.5. On the right, they cross out, and I end up with k equals 90. So there's my constant of variation. Now that I've used those first terms, I cross them out. And let's find y when x is 1. So again, starting with my inverse variation equation, since I'm told to find y stays my variable. For k, now I can plug in 90 because we just found that. And then for x, they tell me x is 1. So my final answer would be y is 90. What is the intensity? You would tell me 90 units. Okay, so this down here in the bottom right-hand corner, 90 units would be your final answer. And that's how you apply this process to a word problem. And there we go. Okay, guys, so really just working with that inverse variation, y equals k over x. Homework 11.1 is going to be your homework for today. It is already in Google Classroom. So this is what that looks like. All right, notice here in the first few problems, you have to plug in numbers to test them out. So plug in 2 sets of numbers and then tell me if it's inverse variation or not. For numbers 5 through 10, these are pretty straightforward. All right, this is just using your equation y equals k over x and just plugging in. Numbers 11 and 12 do bring in the word problems. Okay, so remember, it's always y varies inversely as x. So y always comes first, x always comes second. So the speed in number 11 would be y is inversely proportional to the number of teeth. Okay, so in number 11, the speed is going to be represented by y, whereas the number of teeth is going to be represented by x. In number 12, time is going to be represented by y, varies inversely as the speed. So the speed is going to be represented by x. Okay, guys? So just a few hints there to get you guys going. All right, if you have any questions, as always, put those in the comments, and I'll be more than happy to help you there in Google Classroom. So thank you guys for joining me for this lesson, and I will see you all for the next one.